What is the force between two small charged sphere having charges of 2 into 10 raised to the power negative 7 coulombs and 3 into 10 raised to the power negative 7 coulombs placed 30 centimeter apart in here? Now in this question they are asking us to calculate force here. So force which is equals to what? Question mark here, between two small charged sphere here. Let me draw here roughly, okay, and having the charges, that is one sphere which is having the charge that is 2 into 10 raised to the power negative 7, and here this will be q1 and this will be, that is 3 into 10 raised to the power negative 7 coulombs, and this is what? q2, and place 30 centimeter apart. The distance between these two charges how much? That is 30 centimeter here. Okay, now to calculate the force, what we are having by using this q1 q2 and the distance, the formula we are having, that is F equals to 1 over 4 pi epsilon, and here it is q1 q2 divided by r square. R is nothing but here distance. Okay, now we know this is q1, okay, no problem, here I have mentioned, and this is what r here. Okay, now according to the formula, this is like in the units columns which is there, correct, but this is we have to convert to the meter here. Okay, and now 1 by 4 pi epsilon is nothing but that is k, here q1 q2 over r square. Now k value is how much? That is 9 into 10 raised to the power 9 Newton meter square over Coulomb square here, and q1 that is, okay, I'm going to substitute the values, negative 7 coulombs multiply q2, that is 3 into 10 raised to the power negative 7 coulombs. Okay, now here this we need to convert to the meter here. We know that 1 meter which is equals to 100 centimeter here. Now to convert from centimeter to meter, what we will do, we will divide here. So here I'm having 30 centimeter. To convert to the meter we need to divide it by 100. Okay, and 3 by 10 we can just write it as a 0.3 meter here. Now here 0.3 meter square because r square here. Okay, now let us start simplifying this. 9 into here, before this, okay, 10 raised to the power 9 into 2 3s are 6 into here the bases are same, and the powers what we can do, we can add here. Okay, and it will be 14, negative 14, and c into c, that is c square, whole divided by here it is c square. Okay, and I forgot to mention here this is Newton meter square. Okay, Coulomb square into here I need to multiply 2 times, so I'll be getting that is 0.09 and meter into meter square. Now see here, from this meter square get cancels, and this c square get cancelled here. Now 9 6 is 54 into here. Now look at this, the bases are same, so what we can do, we can add the powers here. So whenever we are adding, we are having here unlike signs. So when I'll subtract, I'll be getting answer as a 5 and the bigger number carrying the negative sign. So 10 raised to the power negative 5, and at the denominator we left with a 0.09, and here we left with the 1 unit, that is Newton. Now 54 over 0.09, when I'll divide, I'll be getting answer as a, that is 600, okay, into 10 raised to the power negative 5 in here. Now this I can write it as a 6 into 10 raised to the power 2. 10 raised to the power 2 is nothing but 100 into 6, that is 600 into 10 raised to the power negative 5 Newton. So finally powers are same, sorry, the bases are same, so powers what we can do, we can add, and after simplifying I'll be getting that is 6 into 10 raised to the power negative 3 Newtons here. Okay, 2 point charges of plus 3 microcoulombs and plus 6 microcoulombs are placed 0.5 meter apart in A. Calculate the force between them. So here we need to calculate the force between these two charges here. Okay, so first of all, force which is equals to what? Question mark here, and what they have given, they have given the 2 point charges. Let me consider here is 1 point and here is 1 point charges, and in one of that is plus 3 and another one is plus 6, and the distance between these two charges is how much? That is 0.5 meter here. Now to calculate the force, what we are having formula, that is F equals to K q1 q2 over r square here. Here q1 q2 which is nothing but charges here, so let me consider q1 as a positive 3 microcoulombs and q2 as a positive 6 microcoulombs here, and r is nothing but here distance, so r we are having that is 0.5 meter here. Now k value what we are having, that is 9 into 10 raised to the power 9 Newton meter square over r square here. Now here which is in the microcoulombs, we need to convert to the coulombs here, and we know that 1 coulomb which is equals to how much? That is 10 lakh microcoulombs. So here, to convert microcoulombs to coulombs, what we need to do? We need to divide by 10 lakh here. So since we are having here 3 and we need to divide it by 10 lakh, okay? And in 10 lakh, how many zeros we are having? That is, we are having that is 6 zeros. So I can write it as a 3 over 10 raised to the power 6, and when I'll bring to the numerator, it will become 3 into 10 raised to the power negative 6 here. So this is converted to coulombs here. Now I'm going to substitute this value, and similarly for this we can say that is 6 into 10 raised to the power negative 6. It has been converted to coulombs now. Okay. Now let me substitute here. Multiply. Q1 value, that is 3 into 10 raised to the power negative 6 coulombs, and the Q2, which is 6 into 10 raised to the power negative 6 coulombs, and here divided by R square, that is, I have written wrong here, Newton meter square divided by, it should be Coulomb square, and now R square value, that is 0.5 meter bracket square here. Okay, now from this let me start simplifying. 9 into 10 raised to the power 9 Newton meter square. Okay, here let me first multiply. 3 times 6 will be 18. Okay, multiply. Look at this, the bases are same, so what we can do, we can add the powers here. So I'll be getting that is negative 12, and c into c, that is c square here. In the denominator, c square into 0.5, we need to multiply 2 times, so I'll be getting that is as a 0.25, and here meter into meter, that is meter square. Now from this, what we can do, the cancellation here, c square it will get cancelled, and 1 meter square and this meter square it will get cancelled. 9 into 18, that will be, that is 162, and look at this, the bases are same, and what we can do, we can add the powers, and since the powers are in the unlike sign, so we need to subtract here. After subtraction, I'll be getting this as a negative 3 here. Okay, and 1, and the unit which is Newton here. Now divided by, only we left with the 0.25. Now 162 divided by 0.25, that I'll be getting 648 into 10 raised to the power negative 3 Newton here. Now when I'll shift to the denominator, I'll be having that is 648 over 10 raised to the power 3 positive 3, and this let me open, so I'll be having that is 648 divided by, here it is, we'll be having 3 zeros. Okay, when I'll convert to the decimal, I'll be having that is 0.648 newtons. Okay, compute the electric force between two charges of 5 into 10 raised to the power negative 9 coulombs and negative 3 into 10 raised to the power negative coulombs, which are separated by distance which is 10 centimeter has been given. In this question, they are asking us to calculate the electric force between two charges. So force, which is equals to what? Question mark here, and the two charges, like here one charge and here is one charge, and the charge between the distance is 10 centimeter here. Okay, and these two charges are, one is 5 into 10 raised to the power negative 9c, and another charge is negative 3 into 10 raised to the power negative 8 coulombs here, and one let me consider as a q1 and another consider as a q2 here, and this is 10 centimeter, which is nothing but what? Distance. So in the formula, what we are having that is r. Okay, so for the formula, I'm going to write F equals to k, and here q1 q2 divided by r square here. Now q1, we are having q2 which is in the coulombs, but the distance we need to convert to in the meter here. Okay, so we know that 1 meter, which is equals to 100 centimeter. Now to convert from centimeter to meter, we need to divide it by 100. So since we are having here 10 centimeter divided by 100, 10 get cancelled, and 1 by 10 we can write it as a 0.1 meter here. Okay, now yeah, everything is there. Now k value, that is 9 into 10 raised to the power 9 Newton meter square divided by Coulomb square, and here it is q1 value and q2 value, I'm going to substitute it here. Okay, that is 5 into 10 raised to the power negative 9 coulombs multiply negative 3 into 10 raised to the power negative 8 coulombs here. Okay, divided by into r value, we found that is 0.1 meter bracket square here. Now here look at this, 9 into 10 raised to the power 9 Newton meter square, and here 5 3 is a 15, and here is the negative sign. Okay, multiply, bases are same, so what we can do, we can add the powers. So I'll be having 10 raised to the power, this is negative 17 here, and in c into c, that will be c square here. Okay, now in the denominator, c square into this we need to multiply 2 times, so I'll be having 0.01 meter square. Okay, now from this meter square and meter square it will get cancelled, and we left with the 9 into 10 raised to the power 9. And I'm going to open this absolute, so I'll be having that is positive 15 into 10 raised to the power negative 17 c square whole divided by, here it is c square into 0.01. Okay, now from this get cancelled here. Now we need to multiply 9 into 15. 9 into 15, that will be 135, and here again the bases are same, so powers we can add. So since the powers having unlike sign, so we need to subtract. So after subtraction I'll be getting that is negative 18. Okay, and here it was a Newton, I forgot to write, and here it is Newton whole divided by 0.01. Now we need to divide 135 over 0.01. So when I'll divide, I'll be getting answer as a 13,500 into 10 raised to the power negative 8 Newton. And further this we can just write it as a 135 into 10 raised to the power negative 6 Newton also we can write here. Okay, since the charges are unlike charge, so it will attract to each other here. A point charge has a magnitude of 3 into 10 raised to the power negative 6 coulombs, and second charge has a magnitude of negative 1.5 into 10 raised to the power negative 6 coulombs and is located 0.12 meter from the first charge here. Okay, so let me write here. Here is the first charge and here is the second charge, and second charge, which is how much distance it is having from the first, that is 0.12 here. Okay, now I'm going to write here, this is q1, this is q2, and I'm going to write the whatever the value it has been given. Okay, and for q2, which is negative 1.5 into 10 raised to the power negative 6. So what we are having, one is positive, another is negative, so there is attraction between. Now by using this value, they are asking us to calculate the determine the electrostatic force each charge exert on the other here. So they are asking us to calculate the force, which is equals to question mark. So what we are having formula, force which is equals to k q1 q2 over r square here. Okay, and here we know the k value, that is 9 into 10 raised to the power 9 Newton meter square over c square, that is Coulomb square, into q1, that is 3 into 10 raised to the power negative 6 coulombs, and q2, which is minus it is minus, but we are going to take it as only just 1.5. Okay, it says that whether it is attractive or a repulsion between the charges. Okay, that's it. Okay, 1.5 into 10 raised to the power negative 6 coulombs. Okay, and here it is 0.12 meter square here. Now from this 1c c square and this c square get cancels here. Okay, now here it is, when I'll open meter square it will become, and this meter square it will get cancelled here. Whatever left I'm going to multiply here. Now we need to multiply 9 into 3 into 1.5 here. After multiplication I'll be getting answer as a 40.5 here, and here it is 10 raised to the power 9 into, here look at this, powers are same and the bases are same, and power what we can do, we can add here. So I'll be having that is negative 12 divided by, here 0.1 we need to multiply by 2 times, so I'll be getting that is 0.0144. Okay, now again here the bases are same, so powers what we can do, we can add here, and due to its unlike sign, so we need to subtract here. So I'll be getting this answer as a 10 raised to the power 9 minus 3, and here it is, we left with a Newton here. Okay, now this when I'll simplify, I'll be getting answer as a 2812.5 here. Okay, now what I will do, this we can just write it as a 2.8125 Newton. Okay, determine the electrostatic force between the two charges of magnitude 2 coulombs and negative 1 coulomb separated by a distance 1 meter in area. So here we are having two charges, and one charge is having a 2 coulombs and another one is negative 1 coulombs here. q1, this is q2, and the distance between these two charges, how much, that is 1 meter here. Since it is having unlike signs, there will be attraction will be there. Okay, now by using this value they are asking us to calculate the force, which is equals to question mark. So what we are having in the formula to calculate this, okay, F equals, which is equals to k q1 q2 over r square. Here r is nothing but here distance here. What we are having the value for k, that is 9 into 10 raised to the power 9 Newton meter square over c square, and here q1, that is 2 coulombs. Okay, and this is, that is negative 1 coulombs, but we are just using here 1 coulomb because it says whether it is, it shows whether it is having attractive or repulsion, that's it. Now the meter, that is 1 meter square. Now see, this c square and this c square get cancelled here. Now this meter square and this meter square, it will get cancelled here. Now we need to multiply 9 2s are 18 into 1, that will be 18 here it is Newton. 1 into 1, that is 1 square only. Since we'll get, I forgot to mention this, is here we are having 10 raised to the power 9 Newton. The force we found, that is this much. Okay. Consider a system of two charges of magnitude 2 into 10 raised to the power negative 7 coulombs and 4.5 into 10 raised to the power negative 7 coulombs, which is acted upon by a force which is 0.1 newtons. What is the distance between the two charges here? So in the system, two charges has been given, that is, let me write here q1, which is equals to 2 into 10 raised to the power negative 7 coulombs, and another q2, which is equals to 4.5 into 10 raised to the power negative 7 coulombs here. And the force has been given, that is F, which is equals to 0.1 Newton. And by using this value, they are asking us to calculate the distance between the charges, which is R equals to question mark. And what we are having the formula? We are having the formula, that is F, which is equals to K Q1 Q2 over R square. Now we need to make a formula for R here. Okay, now let me do the cross multiplication. So R square goes to the left side, and the right side will be having Q1 Q2 over F. Okay, now this square, it is there now, I'm shifting to the right side, so I'll be having now square root and the whatever we are having here. Okay, now I'm going to substitute the values whatever it is here. Okay, now K value, that is before that square root of K value is what, that is 9 into 10 raised to the power 9 Newton meter square over C square. Okay, now Q1 Q2 value which is there now, I'm going to substitute here, and Q2 which is 4.5 into 10 raised to the power negative 7 coulombs here. Okay, now in the denominator we are having, that is force, which is multiply 0.1 Newton here. Okay, from here 1 Newton and this Newton, it will get cancelled, and here it is C square and C into C, that is C square, it will get cancelled. Now in the next step, 9 into 2 into 4.5, after multiplication I'll be getting, that is a 81 into, let me write 10 raised to the power 9 as it is. Now look at this. Okay, same bases are there, and powers, what we can do, we can add here. So we'll be having negative 14 divided by 0.1 here. Okay, now in the next step, square root of 81 into here, look at this, bases are same, powers are, what we can do, we can add here. Since the powers, it is having unlike sign, so we need to subtract. So after subtraction I'll be getting negative 5 here, and here it is 0.1 which is in the denominator. So 0.1 I can write it as a 1 by 10 here. When I'll do the reciprocal, it goes to the numerator. I'll be having 10 raised to the power, I'm just going to write it as a 1 here. Okay, for the further calculation. Now here square root of 81 into, the bases are same, again 10 raised to the power minus 4 here. So here I can write like 9 square into here 10 raised to the power negative 2, again raised to the power 2 square root here. Now if I take 2 as a common, this square root and 2, it will get cancelled. We left with a 9 into 10 raised to the power negative 2, and let me bring to the denominator. So I'll be having 100 when I'll open it. So when I'll convert to the decimal, I'll be having 0.09. Since it is in the distance, this is a meter here. Okay, I forgot to mention here it is, we left with the m square. Let me write everywhere m square, which is under the square root only here. Okay, up to here and up to here, again with the this two powers, it will get cancelled, and we left with the 1 meter. Okay, so distance between these two charges, which is 0.09 meter here. Determine the magnitude of the two identical charges when the electrostatic force between these two identical charges is 1000 newtons and are separated by the distance of 0.1 meter here. So in the question, it has been said that two identical charges, it means the both charges are what, it is same. So if I consider Q1 which is equals to Q, Q2 will be what, that will be also Q here. Okay, now the force between these two charges is how much, that is 1000 newtons. Okay, and the distance has been given, that is R equals to 0.1 meter here. By using this value, they are asking us to calculate this one. We need to calculate the identical charges here. So what we are having the formula here, we are having the formula, that is F, which is equals to K Q1 Q2 over R square here. Now in the next step, Q1 and Q2 we have considered as a QQ. Okay, Q into Q, that will be Q square over R square here. Okay, now let me make a formula for Q square here, I mean Q. Okay, now in that case, after doing the cross multiplication, R square goes to the left side, so I'll be having F into R square divided by K comes in the denominator. Okay, and when I'll shift this square to left side, so it will be having square root of F into R square over K. So this is what I made a formula for Q here. Okay, and whatever the values we know, we will start substituting. That is Q, which is equals to square root of F, that is 1000 Newton, into R square, that is 0.1 meter bracket square, over what is the K value, that is 9 into 10 raised to the power 9 Newton meter square, over C square. Okay, now in the next step, look at this Newton it will get cancelled here, and I'm going to multiply 1000. So when I'll multiply 1000 into 0.1 into 0.1, I'll be getting, that is 10 here, and before that this m square and this m square, it will get cancelled, and C square, when I'll do the reciprocal, it comes in the numerator. Okay, divided by 9 into 10 raised to the power 9 we are having right now. Now in the next step, what I will do, 10, I can write it as a 1 into 10, still will be getting 10 only. So this 10 I'm going to send to the denominator. So when I'll send, it will be getting, that is 1 by 10 raised to the power negative 1, right? Okay, square root of 1 by 9 into 10 raised to the power 9 into 10 raised to the power negative 1, and we are having here C square. Okay, now in the next step, the same bases are there, so what we can do, we can add the powers here. So in that case, we'll be having, that is 10 raised to the power 8 here. Okay, now 9 I can write it as a 3 square, right? And this 10 raised to the power 8 I can write as 10 raised to the power 4 bracket and raised to the power 2. Okay, and here 1 it is there, no, we can write it as a 1 square. 1 square is nothing but 1 only here. Now all the powers I'm going to take it as a common here, so I'll be having square root of 1 by, here it is C square, it is there. Okay, that also I'm going to take a common here, 3 into 10 raised to the power 4, write the C here, put it all in the bracket, and I'm taking the power 2 as a common here. Now this square root and 2, it will get cancelled here, so we have now 1 by 3 into 10 raised to the power 4 coulombs. Okay, I made a small mistake actually, C square which has been shifted to the numerator. Okay, I had to show here. Okay, fine. Now when I'll divide 1 by 3, I'll be getting answer as a 0.33 into 10 raised to the power, shifting to the numerator, I'll be having 10 raised to the power negative 4 coulombs, or we can just write it as a 3.3 into 10 raised to the power negative 5 coulombs here. Therefore Q value we found, that is this one, right? So here the both value is how much, that is 3.3 into 10 raised to the power negative 5 coulombs for both, because since it has been said that it is identical. Okay.